So we've talked about solving systems of equations and equations, basically linear equations. And now we're going to talk about our linear inequalities. So if you remember what an inequality is, an inequality is an expression that instead of using an equal sign, you use a symbol such as greater than or equal to, or less than or equal to, less than, or greater than. All of these represent different types of things. The first one represents the fact that the solution would be 5 exactly, because it's or equal to, or anything bigger than that. So we shade it in this direction. The second one represents the fact that the solution would be 5 because it's or equal to, or anything less than. Third would be that it's not 5, but it's anything less than 5, and so we have an open circle. And the last one would represent it's not 5, but it's close to 5 and anything greater than. So with that same concept in mind, we talk about linear inequalities. A linear inequality is similar to a linear equation, but the difference is that you use an inequality symbol and that the solution of the linear inequality is any ordered pair that makes the inequality true. So for example, if I was to say something like graph y equals 2x plus 2, this is an equation, and the normal way that I would graph it would be I would go to 2, and I would go up 2 over 1, and then I would connect the dots. And the line that I would get would be a solid line. The difference with that as an equation and the inequality, which you see actually listed here, is that when you have something like y equals 2x plus 2, your answer is a solid line and that's it. When you have something like y is less than 2x plus 2, you graph it in the same way. So you would begin at 2 and you go up 2 over 1, up 2 over 1, but because the inequality symbol that I'm using does not have the extra ink underneath, it's less than, you use a dotted line, and that's the reason to why this is dotted. And less than means it's below the line, and so you shade below the line. What this is representing is that any answer, any ordered pair inside of this would make this inequality true. So let's choose, 0, 0. 0, 0 is a point within that shaded area. 0, 0 would say that the y value, which is 0, must be less than 2 times the x value, which happens to also be 0, plus 2. And in this case, 0 is less than 2, yes. So that means that the solution that I shaded to below the dotted line is correct. So the big difference with linear equations and linear inequalities is that linear inequalities, you are going to graph with either a solid line or a dashed line, kind of like less than equal to and greater than or equal to had a closed circle. You have a solid line. And if you have the symbol without the inequality underlined, you have a dashed line. And the reason it's dashed is because it's not every single point on that line is going to make it true. Then greater than would shade either above or to the right. Less than shades below or to the left. A lot of this has to be trial and error because sometimes you're going to shade and then you're going to check your work and it doesn't work. So let me explain what I mean by that. So just as a quick refresher, what we just said, when the inequality symbol is or equal to, the points that are on the actual line are part of the solutions, therefore the line must be solid. When the inequality symbol is not or equal, the points that are on this line are not solutions, and therefore the line has to be dashed. When the inequality is greater than or equal to, you shade above the line. When it's less than or equal to, you shade below the line. So let's look at an example. The first question is to see if the solution is, to see if the ordered pair is a solution. So you're going to perform the same exact thing you did with the equation to see if it's a solution. If these are my x and y values, you're going to plug them into the inequality. Y is less than 4 plus 1. 4 meaning x. Is 5 less than 5? No, it's equal to it. So that's not a solution. For the next one, x and y are both 1. 1 is greater than 1 minus 7. Is 1 greater than negative 6? Yes, it is. So that point is a solution. When you're solving when you're graphing linear inequalities, you are going to first make sure that you put it in y equals mx plus b. That's the very first step, because when you have it in that form, and remember, we're not using the equal to sign, it's either going to be greater than or less than. When you have it in that form, it's easy to graph. So the first one, y equals 3x plus 4. Y is less than 3x plus 4. Graph it like a normal slope-intercept. Begin at the 4, because that's the y-intercept. And the slope is 3 over 1, so that means you're going to go up 3 to the right 1, up 3 to the right 1. You can extend it in the other direction. Now you're going to ask yourself, is it a solid or is it a dashed line? There's no extra ink, so it's not solid, it's dashed. Now, this symbol says less than. Less is below. So I would presume that all of these areas in the shaded area, all of these points in the shaded area are solutions. Now you always check your work. So you pick a point. Let's pick this one, 5, 0. Let's check our work. If I shaded correctly, then 5, 0 should be a solution. So x is 5, y is 0. So is 0 less than 3 times 5 plus 4? 15 plus 4 is 19. 0 is definitely less than 19, so I know I shaded it correctly. In order to graph this, once more, we want it in y equals mx plus b. But instead of an equal sign, we use a symbol. It's in standard form, so I am going to subtract 3x. I get 2y greater than or equal to negative 3x plus 6. Now I need to divide everything by 2. And I get the new equation, or the new inequality, and I apologize, I keep saying equation, but it's an inequality. Y greater than or equal to negative 3 halves x plus 3. Y-intercept is 3. Slope is negative 3 halves. So I go to 3 on the y-axis, and I'm going to go down 3 to the right 2, and keep going until I have several points. Now I need to know whether it's solid or dashed. It's an or equal to, so it is solid. And I need to know which direction to shade. That's a greater than. Greater than means above. And check your work. I'm going to check my work with, let's say, this point right here, 4, 2. So if 4, 2 is the solution, I know I shaded correctly. X is 4. 3 times 4 plus 2 times y is 2 is greater than or equal to 6. 12 plus 4, is that greater than or equal to 6? Yes, it is. So I know that it's correct. The last type of question that you're going to be asked is you're going to be given a graph and you're going to be asked to write the inequality. So when you do that, step 1 is to find whether it's a solid or dashed. So you want to know whether it's an or equal to or an not an or equal to. Remember, when you have or equal to, it's solid. When you have not or equal to, it's dashed. It's dashed, so I know it's one of these two symbols. Then you want to know whether you are greater than or less than. Well, you are shading below the line, so below would represent the less than. So I know it's a less than symbol. So as I write my y equals mx plus b. I know it's y is less than something x plus b. The slope and the y-intercept are the only things you need to figure out. Well, the y-intercept is 2. As you could see, that's 2. So I'm going to replace the slope, or I'm sorry, the b, with 2. So this is 2. Now I need to find the m. Well, always try to see if you can identify perfect points. And by perfect points, I mean exactly where they cross two lines. For example, this point here, it crosses right here. So that one's perfect. It's a perfect point because I could see that it's right there. And I know that the other point is here. I went down 1, so I'm negative 1, and over 1, 2, 3. So my inequality is y is less than negative 1/3 x plus 2. The next question, same type of question. Now I have a solid line, so I know it's either less than or equal or greater than or equal. It is shading to the left. Now you think to yourself, well, is that above or is that below? That's what I would always confuse myself as. So I would look at it and go, well, if I'm looking at the number line, normal number line, everything to the left is less. So I'm going to start off by thinking that it's less than or equal to. My y-intercept is negative 2. And the slope, well, I could see this point is perfect as well as this one. My slope is up 1, 2, 3, 4, 5. And to the right 1. So my slope is 5. So now I'm going to write my perspective equation, which I believe is y is less than or equal to 5x minus 2. Now, in order to verify that you chose the correct symbol, you pick a point within the shaded area. Let's look at this one. 0, 0 is probably, again, one of the easiest ones to work with, so make it easier on yourself. Let's check to see if 0, 0 satisfies the inequality I wrote. Is 0 less than or equal to 5 times 0 minus 2? Is 0 less than or equal to 0 minus 2? Is 0 less than or equal to negative 2? No. So that means that my inequality symbol was incorrect. It must have been greater than or equal to. Check it now. Is 0 greater than or equal to 5 times 0 minus 2? Yes, because 0 is greater than or equal to negative 2. So therefore, the inequality symbol is greater than or equal to. So pay close attention to when you're identifying what symbol to choose. If it is above the line, and if we look at this, it's above the line. But the errors we make is we think it's to the left, which means it's less than. So when you go to choose your symbols, make sure you check to see if it's correct. It's above the line. If I had this line, I would think it's above because it's going above the line. Everything down this way is below. Here it's above. The last example that we are going to work on, example C, is a special case line. We know this is a vertical line, and vertical lines have undefined slopes, and they are x equal to equations, VUX. That means that this equation, because it's a special case, is x equals wherever I cross my x-axis, which happens to be negative 2. And in this case, because it's not just an equation, it's an inequality, instead of the or equal to symbol, I am going to use one of the symbols that's underlined. And because everything to the right is shaded and there's no doubt about whether it's above or below, to the right is always bigger, then your symbol is greater than or equal to. And you can choose a point. 2. If x is 2, 2 is greater than negative 2, so you know it's correct. Just as a quick reminder, if I had had an inequality that was a horizontal line, and it was dashed, and it was shaded below the line, then my inequality would be a y. Remember Vux Hoi. It's a horizontal line, which has a slope of 0, and it's a y equal 2 equation. In this case, I am crossing y at 3. So this is y equals 3, but because it's an inequality, and it's dashed, because it's an inequality, and it's dashed, I'm shading below, which is less than, and not an or equal to. And so that's what that one would be like. You will be completing the independent practice, all of these, numbers 1 through 6. So please be sure to complete the independent practice and upload it to Canvas. That is your assignment.